Hello everyone, my name is Benjamin Debucher and I'm the head of events content for JEC Group. Thank you for joining us today. Today's webinar is Polymer and Ceramics Matrix Composites for innovative applications. As you all know, we are in a context of much tougher regulations when it comes to flame retardant materials and materials that reduce smoke emissions. This is especially the case in the aerospace and automotive industries, but as we will see, it's also relevant to other industries, from defense to sports and marine. Today, we are talking about a completely new composite material that responds to these needs. This new material is called C-Preg 400. It's a cutting-edge, easy-to-use, and non-toxic prepreg, combining both very good thermal stability, up to 400 degrees, and excellent flame retardant properties. This material has been created by Nano-Tech and Petroceramics. So who are Nano-Tech? Nano-Tech is a young company based in Italy. It designs, produces, and sells composites material from thermosets to thermoplastics, with or without nanoparticles. Its R&D focuses on bringing innovative materials to the markets that meet customer needs and allow them to use nanotech materials without changing production processes. We will be hearing from Andrea Giovanelli. He is the company's co-founder and general manager. Andrea is a mechanical engineer with extensive experience in nanocomposite fabrication. We are also talking with Petroceramics. Petroceramics are another dynamic Italian company designing and developing ceramics and composites for high temperature applications, especially in automotive, aerospace, and defense. We will be hearing from Petroceramics senior researcher, Fabio Giacometti. He's been with Petroceramics R&D since 2015, and he is a specialist in composites and their application in automotive and aerospace. So, how Cpreg 400 is a cost-effective alternative to Siana tester, bismalamide, and polyamide? How can you work with Cpreg 400? What are the applications and future possibilities of Cpreg 400? We will answer all these questions in the next 60 minutes. Of course, at the end of the webinar, we'll be taking questions. So you can ask your question in the question tab here on the right of your screen, and I will be reminding you again during the webinar. To maximize the experience of the webinar, I recommend you to be connected through cable wire rather than Wi-Fi. And this webinar is currently being recorded, so you will be able to view the entire program later on gccomposites.tv. So let me open the floor to Andrea Giovanelli, the co-founder of Nano-Tech, and to Fabio Giacometti, senior researcher at Petroceramics. Andrea, Fabio, welcome on stage. Could you please give the audience a short introduction of Nano-Tech and Petroceramics? You're mute. Andrea, you're mute.
I'm sorry. Let's start with Nano-Tech. Thank you, Benjamin. We will start with a little video showing where we are, and I will tell you what we are doing. There is a little audio registration. Our expertise lies in materials, how they are made, how can be used, and how they can be improved. We champion the nano-evolution by designing the material of the future. Materials that are stronger, lighter, more durable, high thermally resistant, and electrically conductive. Thanks to our patents and know-how, we go beyond the limits of current technologies, making materials that are multifunctional and easy to use. We are situated in Italy, in the Marche region, close to Ascoli Piceno. Our plant, with 2,000 square meters between production and offices, hosts 16 people. In this plant, we develop and produce our resin systems and our prepregs using hot melt technology. We are certified ISO 9001 by EPAVE. The world company meets the requirement of Industry 4.0, and most of the machines are connected with the ERP in order to guarantee the maximum quality. And most of the machines are connected with the ERP in order to guarantee the maximum quality. Thank you, Benjamin, for the video. Last things I would like you to know before starting to present at a glance the product of Nanotech is that at Nanotech we are not producer of nanoparticle. So we are not interested in one particular kind of nanoparticle. We test always new solution. So we have a lot of nanoparticle already tested, and we use nanoparticle just when needed in order to obtain multifunctionality of the materials. The third thing is that we are able to formulate our own resin system. And we do this to have products that are not changing the production process of the customer. So let's start a bit about the product. At Nanotech, we started formulating Nano-4C epoxy resin. That is a nanostructured epoxy resin, nanostructured with the multi-walled carbon nanotubes. The resin is suitable for a lot of different processes, like bonding, wet layup, repairing of damaged composite structure, and has also been used for compression RTM. We have a multifunctional coating that is MG coating, that is a primer, epoxy primer, easy to apply, that have the possibility to damp vibration. So it's useful for light structure in order to have a corrosion protection and a lightweight solution to dampen vibration. Then we have a range of thermoplastic polymers, the Nano-4S. We have two versions, TPU, so thermoplastic polyurethane, and polypropylene. The polymers are loaded with carbon nanotubes in order to have a very high electrical conductivity, in order to be used for electrostatic discharge, EMA shielding, and the sensor. Then we go to our core business, that is the production and sales of prepreg. We developed a range of prepreg from, let's say, more general purpose to very special products such as Cpreg that we will see later. Here we can see at a glance the N125T, that is a toughness epoxy matrix for general application with very good structural properties, very good aesthetic result, so can be also used for aesthetic components. And the material has a TG of 125 degrees and can be used also for a sandwich component and monolithic structure. Then we have the Nanolite N125L, that is a nanostructured epoxy prepreg with about 125 degree TG. We use nanoparticle in order to have a very particular behavior, logical behavior of the resin that allow us to obtain prepreg that are more light. So you can have a light reduction up to 12% compared to the main prepreg on the market with the same layup. Then we use the nanoparticle in order to increase the overall mechanical properties of the composite, in particular the compression strength. As you can see here, a comparison between most of our competitors. We are one of the best in class in compression properties. This was a test done in high strength wheel carbon fabric. Here there is the Cpreg that we will talk about in all the rest of the webinar, so I will not, I will go further. And we recently developed a toughened epoxy prepreg for general application, but in particular is for press molding. The current cycle, it's 15 minutes at 150 degrees. So you can have a aesthetic component without white dots and very low porosity, and you can fast your production process against the normal autoclave processes. Then we developed this composite that is a Cpreg N140F, that is a flame retardant epoxy prepreg, special designed to comply with the fire smoke regulation, so the FAR and UL 94. It's ideal for panel and secondary structure. It's already under testing for interior in aerospace. It's available in carbon version, also glass fabric version, and it has very good mechanical properties. Then we are inside also a project with that is MARLIC project, Mark Applied Research Laboratory for Innovative Composite. And this is a project of 3 years with 21 companies and 5 research centers, where we are studying and developing bio-based composite, starting from a natural fiber, and studying also natural source in order to obtain bio-based resin, to have more eco-sustainable products. We are currently in, our markets are currently Formula One, racing, aeronautical. We have some little application tested in space. We are in the motorbike, and we are entering also in a marine market. We are in the sport goods market from many years, and with the NG coating, we are also working in white goods application. Thank you for the attention, and now I let Fabio to speak about Petroceramics.
Thanks, Andrea, and thanks everybody for joining us today. My name is Fabio, and in this part of the presentation, I will introduce Petroceramic. I just will give you a short introduction of the company, and then we will talk about our high temperature composites, and I will take you through the variety of solutions we have for different temperature ranges, and we will make the thermometer kind of blow up during the presentation. And in the end, some further solution we can provide to our customers. So Petroceramics was founded back in 2003 as a spin-off of the University of Milan, and it had a laboratory set up working mainly on ceramic, advanced ceramics. In 2007, we started running R&D on innovative materials for braking systems applications, especially carboceramic composites, oxidation protection, and friction materials, because of the collaboration with Brembo. In 2008, we obtained the quality certification, and then we moved to the Scientific and Technological Park Chilometro Rosso. Since 2010, we have broadened our expertise to also other materials by applying the well-consolidated know-how we have on LSI, liquid silicone infiltration, on new materials such as boron carbides for armor application. In 2014, we started working on our own R&D composites with complex structures for automotive and other applications, and we've broadened our expertise and experience to other applications. So we, for example, started working on Polymer-Matrix Composites for high temperature applications, such as prepreg, Cpreg 400. And then also we kept working on ceramic matrix composites for even higher temperature applications. And our solutions now find application also in the aerospace sector, among the others. So our facility consists of a production prototyping lab, which has an autoclave and compression molding pressings to shape our products. And then we have furnaces for the binding and pyrolysis, and kilns for sintering. We can work up to 2600 Celsius degrees in vacuum. We can work up to 2200 degrees in 100 bar of inner gases, and up to 1750 Celsius degrees in air. And in our analytical lab, we can characterize the materials on the point of view of mechanical properties, thermal properties, physical textures, and a lot more, as you can see from the images. And so our composites for high temperature applications, they are all carbon fiber-based composites. And as you can see, we have a wide range of temperatures. We can start with Cpreg 400, that will be described in depth later together with Nano-Tech, which is thought to work up to 400 Celsius degrees. But there are applications which require even higher temperatures application and resistant to prolonged exposures. And for this application, we propose the Cpreg, the PIP composites, which can withstand 800 Celsius degrees. But if this is not enough, we have a line of carboceramic composites, so carbon matrix composites, which can withstand prolonged exposures up to 1400 Celsius degrees in inert or low oxygen atmospheres. And these materials find application in the aerospace sectors, among the others, for which they were originally developed. We also developed a specific protective coating that allows these materials to withstand even higher temperatures, as you can see. So as you can see, we can provide different solutions for different temperatures, for different exposure duration, and based also on the desired properties. So basically, based on your needs, we can propose different materials. In the case of Seprec 400, we select together the fibers and the fabrics. Molding and curing can be performed by us or by the customer, and in the latter case, we will put you in the condition to process it properly in order to get very good quality end products. So we can sell either the end product or the prepreg. In the case of ceramic matrix composites, so PIP composites and EasyComp, we select the material based on your requests, and molding, curing, and conversion into a CMC are performed here in Petroceramic because this is our consolidated know-how.
Fabio, sorry to interrupt. I have a question on this slide. So I understand there is no possibility for the customer to take care of the shaping processes in the case of PIP or IC-Comp?
Okay, well, this is our standard approach. So generally we do this way, but in some specific cases we could discuss with the customer and we could provide them with the prepregs. They could do the shaping, so the molding and the curing, and then send us the material for the conversion into a CMC. But this needs to be discussed together face-to-face with the customer. So we will evaluate every situation. Thanks for the question.
Thank you, Fabio. Just a quick reminder to the audience that you can ask your questions to Andrea and Fabio directly in the question tab on the right of your screen, and I will be asking those questions to them at the end of the webinar. You can go, Fabio.
Okay, thanks. So as for PIP densified CMCs, we can handle complex shapes and flat shapes, as you can see from the images in the bottom right. And there are no main restrictions as for the dimension of the objects. So we can perform shaping in compression molding presses or in the autoclave, depending on the shape of the object. And now we have a pyrolysis in order to open porosity and prepare the material for densification. And densification is obtained by means of PIP, so polymer impregnation and pyrolysis. And we can run 3 to 10 cycles of PIP densification, depending on the final density and porosity that is needed for the material. But in the end, as you can see from the SEM images, the polymer matrix will be completely converted into a ceramic matrix. In the box on the bottom left, you can see some characteristics that we can achieve in our fully densified composite. But as I mentioned before, we could get more porous and lighter objects and also with different thermal properties. And we can tune these characteristics by changing the number of PIP cycles and by changing the temperature of pyrolysis, basically. So moving to higher temperature application, we have one of our leading trademark, EasyComp. Also, in this case, we select the material and perform all the steps of processing from molding to conversion into a carboceramic matrix composite. In this case, after pyrolysis, densification is obtained by means of liquid silicone infiltration, which is faster and way cheaper than other ceramization techniques for these materials, such as silicon carbide CVY. The whole process lasts less than 10 days instead of weeks, for example. And also in this case, we can handle with complex shapes and different dimensions. So we can select different fibers and matrices and fabrics because we can obtain tailored microstructures which confer some peculiar mechanical and thermal physical properties to the end products. In the box below, there are some characteristics of our standard EasyComp, but as you can see, we have always new materials being developed, because basically we can tune the products as it is best for the final application. EasyComp can withstand prolonged exposure up to 1400 Celsius degrees in inert or low oxygen atmospheres, and for this reason, it is the fitting composite for some aerospace applications. With EasyComp, we developed, together with the Italian Center for the Aerospace Research, CIRA, some components of the Space Rider vehicle of the ESA. To better protect our EasyComp from extremely wearing conditions, we developed an innovative silicon carbide coating. You can see on the right the SEM image that shows the amazing interface between the composites and the composite and its coating. For this reason, silicon carbide coated EasyComp was selected by CIRA to manufacture some components of the thermal shield of the reusable Space Rider vehicle by the ESA. And in these pictures, you can see the flap and the nose of the vehicle. The mechanical resistance of the coated EasyComp was also tested through a simulation of real mechanical stresses, which the flap will undergo during the launch of the vehicle. And tests were performed by CIRA in their facility. So if Benjamin, could you please start the video? Okay, I will just give you a short view on the different steps of the simulation. You will see the increase of the frequency of vibration as I move forward. Okay, as you could see, vibrations were pretty intense, and no damage were reported on the object. Oh, sorry, I cannot skip. Okay. So besides, also the samples and the end products were tested in order to simulate the thermal and oxidative stresses that they will undergo during several missions. So they were tested in the plasma wind tunnel facility by CIRA, and after testing, which consisted in exposure up to 1650 Celsius degrees, negligible mass loss were observed, and mechanical properties were maintained. Only some partial oxidation was observed on the silicon carbide coating, but this was expected, basically. And this is what I've shown till now. We can work a lot on targeted complex structures and shapes for different applications. We can tune texture and matrices. We can work on protective coatings to give you tailored solutions to optimize specific properties and satisfy your requests. So, for example, in the box below, you can see some coil structures that are currently being used for the production of carboceramic braking discs and for some application in the aerospace industry. We can also improve the thermal properties of 2D composites by, for example, with our needler, and we can combine the two above mentioned, so coiled structures and needle structures, to get tailored structures and optimized solutions. We can also produce sandwich products with different materials, with different composites, and we work a lot with matrices and textures, as I've already mentioned. So I thank you for now for the attention to this part of the webinar. You can see our emails there, and I will skip to the part relative to.
Thank you very much, Fabio, for giving the audience more information about Petroceramics, and thank you, Andrea, for the information about Nanotech. I think it's now time to discover more about Cpreg 400. Could you please let the audience know what the key properties of Cpreg 400 are? And I remind you also, the audience, that you can ask your questions again in the question tab on the right of your screen.
Thanks, Benjamin. In this part of the webinar, Andrea and I will talk about Cpreg 400. It is an innovative prepreg which was created by Nano-Tech and Petroceramics. It is a heat and flame resistant prepreg which was classified V0 according to the UL 94 flammability standards. And this innovative prepreg is therefore suitable for high temperature applications. It is currently being used in the Formula 1 and MotoGP championships, and it is being validated for interiors in the aerospace industry. So in this section, you will get to know more about the ease and safety of handling the prepreg, about how the prepreg can be processed in order to get high quality end products with a certain processing flexibility, about the good thermal stability up to 400 Celsius degrees, and about the amazing resistance to heat and fire, and also about the competitiveness with other resin systems. So Cpreg 400 is harmless and non-toxic for users. If you see the extracts of some safety data sheets of the Cpreg 400 and extracts of those from other commonly used systems for high temperature application, well, you can see that in the safety datasheet of Cpreg 400, there are no hazardous statements, whereas phenolic cyanide ester-based systems and epoxy-based systems may have some or several hazardous statements.
Fabio, just a quick question regarding SDS comparison. I didn't get why the Cpreg 400 hasn't had a risk phrase.
Okay, basically it is because this is a siloxane-based system, mainly consisting of silicon and oxygen with very little amount of solvents. So basically it is safer than systems that have free phenol or formaldehyde, or systems that have free polyamine or epichlorine and whatever. So this is the reason why it's safer and has no hazardous statements. Thanks for the question. Okay, now Andrea.
Okay, now let's talk about the curing process. The Cpreg 400 can be cured in autoclave. It has a 5-hour dwell at 180 degrees. And he needs to be post-cured at about 250 degrees for 600 minutes. This to achieve the maximum TG of the material. The material can be also cured by meaning of compression molding at 250 degrees for 90 minutes. And then if you want to achieve best properties, you should perform the same post-curing cycle. It has also the possibility to be cured in a hot-in, hot-out process. So you can take the mold hot at 250 degrees, and you can put your laminate of Cpreg up and press it for 90 minutes. And get it out and put another one inside without letting the mold cooling down. So as you can see, the Cpreg is quite easy to use and flexible, and the process flexibility allows everybody that has an autoclave or a press to use it.
Okay, thanks, Andrea. Okay, so basically the the special inorganic composition of the composites and of the resin allow the amazing stability of the cured composite in oxidative conditions at even at really high temperatures, as you can see in this graph. We have thermogravimetric data, and here the weight loss is reported, and it is very negligible in the case of Cpreg 400, even at high temperatures such as 900 Celsius degrees. But see what happens to other resin systems that are commercially available for high temperature applications. You see the drops of the mass percentage, you know, in the curves here, which indicate that the matrix is being deteriorated at temperatures lower than 500 Celsius degrees. And also, we performed some isothermal aging to check the weight loss over prolonged exposures at 250 degrees up to 900 hours. And you can see we have very negligible weight losses because they are less than 1.5%, and most of it is at the very beginning of the tests, and it is ascribable to mostly to sizing of fibers and to the complexion of the curing of the composite. We also performed isothermal aging to check the weight losses at higher temperatures. So we tested for 100 hours of exposure at 350 degrees, and you see the little weight losses. And also we tested for 24 hours at 400 Celsius degrees. So basically, we can say that we have good thermal stability over temperature and over time, and good thermal stability is reflected also in stable mechanical properties over prolonged exposures at those temperatures. So in these images, we can see the Young's modulus that was tested during continuous thermal exposures in our DMA facility. So we exposed the samples at 350 degrees for 48 hours, so a couple of days. And we exposed the composite to 400 Celsius degrees for 24 hours. And you can see that at 350 Celsius degrees, basically the Young's modulus maintains stable. And at 400 Celsius degrees, we have a slight deterioration of the Young's modulus after 18 hours, but there is no major drop of the curve. And also some further DMA testing was performed to see what happens at different temperatures to the elastic modulus, which is here reported on a relative scale. In the case of Seprec 400, you can see the huge stability even at high temperatures, such as 400 Celsius degrees, whereas in the case of a commonly commonly utilized system, cyanate ester-based prepreg, you can see that we have degradation of the matrix at temperatures lower than 250 Celsius degrees, and these affect the Young modulus at the 3-point bending test, even at low temperature, as I said.
Okay, let's see how the product is available on the market. We have here you can see an example of what we can achieve in terms of final laminate density, current ply thickness, and resin density after curing and post-curing of the composite. I hope to answer also to some questions that I'm already seeing through the question box. The material, it's standard material, is available in fabric, carbon fabric. It's high strength wheel carbon fabric, but we can also do some kind of bespoke material. So feel free to ask us different fiber and different fabric, and we can manage to do it. This is the one that we have best characterized. So let's see at a glance some mechanical properties of the material. Here you can see a characterization at room temperature of the material with ASTM standards. As you can see, the modulus and tensile strength are comparable with the epoxy system at room temperature. What is not comparable is the interlaminal shear strength, but as I say every time, you cannot bring epoxy system at 400 degrees. And here we have something about the fire properties of the material. Being Cpreg a high inorganic resin, it is intrinsically performing better than when exposed to heat and fire compared with organic counterparts. As before mentioned, Cpreg 400 is heat and flame resistant prepreg, and it's compliant with the UL94 classified V0 flammability standard. This makes it particularly suitable for high temperature application and can be used to produce thermal barrier, exhaust system, engine parts, and other components for high performance braking system. Our laminates were tested according to FAR standard, the Appendix F, and they meet the requirement in terms of vertical flammability, heat release, and optical smoke density. The value obtained are comparable and even better than the one with Phenolic, as you can see, and way better of the normal epoxy flame retardant. As you can see here, among the acceptance criteria, Cpreg 400 has a very, very short burn length. It's not taking fire, basically. It has not ignition. And the heat release is also very low. What is also very important is that against the organic counterparts, as you can see here, there is basically no smoke. Because of 200 of acceptance criteria, optical smoke density, we have 0.4 against 18 to 160 of the other system. Here we will show a little video of the FAR test vertical flammability. Thanks, Benjamin. The video lasts a bit more than 1 minute. We keep it wall, so you will see the test. As you can see, there is no ignition, so the material is not burning, and will not burn for all the minutes of the test, as you will see. It's already 50 seconds, about 50 seconds of testing. No ignition at all. Okay, here we have a picture of the specimen after the testing. As you can see, there is just a little sign of smoke on the specimen. We tried to do 2 different thickness. And I don't think with other organic material you can achieve those properties. Then we will show a chart done by the Calorimeter test. This is the chart of heat release of the specimen. And you can see we tested a normal flame retardant epoxy against our Cpreg. As you can see, there is no ignition time. The heat that was supplied was 35 kilowatt per square meters. As you can see, after even 10 minutes, there is no, basically not heat release. While the epoxy composite come against to 0 because basically there is no more composite in the Calorimeter.
Yeah, just to, sorry
yes.
to interrupt, Andrea, just to clarify, so what is the epoxy curve meaning compared to the Seprec?
Yes, sorry, it's the white line is the epoxy. As you can see, the heat release is coming out after 100, basically 150 seconds. That is the ignition time. And the Sepreg, that is the orange line, it's remain close to 0. For all the time of testing, that is about 10 minutes.
Thank you.
Thank you, Benjamin. And this is the chart taken from the same test, the Calorimeter test. This is the part that show you the time against the sample mass. As you can see, the mass of Cpreg remain close to 100% of the original mass, while after the ignition, the epoxy is starting to lose mass and is going close to, let's see, 65–70%. So it basically lose more, let's say, all the organic part. And after this, I let to Fabio speak a bit about the thermal conductivity specific heat, because this is the part of the knowledge of Petroceramic.
Yes, because basically we have shown the great stability that our resin system confers to Cpreg 400. So Andrea showed the very good flammability properties, the very good fire properties, the very good resistance to heat. And besides, the thermal conductivity and the specific heat of our composite are aligned with those of standard Polymer-Matrix Composites. So this is very good, and thanks to the thermal properties and to the thermal stability, Cprec 400 is particularly suitable for heat-resistant thermal barriers alone or in sandwich structures. And in particular, it is very easy to join the prepreg with aluminum honeycombs. Okay, Andrea, you can go on.
Yes, thank you, Fabio. Here also, I hope to be able to answer to some questions. Here we have a chart. As you can see, we did a comparison. We don't have very accurate dots because it depends on the fiber and fiber weight, of course. But here you can see the price of Seprec is in the right range for a high temperature prepregs, but is comparable with Cianata ester and on average lower than a polyamide. Compared to the other organic composite, we offer a sensitive advantage that are very high thermal stability. We say up to 400, but it can go even higher for a short period of time, maintaining the shape. The highest TG on the market, even higher than the polyamide. And we have also good drapability and workability. So you will not have the issue you may have with the other prepreg. And also, as we said before, it is safe to use, as it is not with phenolic resin, polyamide, and other organic resin. Now we will talk a bit about application. We have here a Formula One. We cannot say a lot about it because we sign, of course, NDA, also because Formula One is always trying to go further, exploring new application. But what we can say is that it has been used for brake system, heat barrier, exhaust insulation. And we can imagine that all the hot area can be eligible for the Cprec 400 use. It is now more than 3 years that has been used in Formula One, and it also entered in MotoGP, as Fabio said before. Here also we have a picture of a Honda Special Embarcadero by Embarcadero that did the exhaust with totally with the Cpreg, so diminishing the use of metals and gaining a lot of weight compared to normal exhaust system. We have an example of a gas exhaust pipe for high temperature made with Cpreg 400. This is quite big object, let's say, that was obtained by curing in autoclave and then post-curing in oven. And we did even a paint test of the composite with good result. Cpreg 400 has also been chosen for a satellite application. Also here we cannot say too much because of the NDA we signed with the companies, but we are proud to say that will soon be in space. And the material, last but not least, has been qualified for use in aerospace, civil aerospace interior, in particular in helicopter. So thank you a lot for joining the webinar. I will
thank you very much, Andrea and Fabio, for this great presentation. I will now open the floor to questions, sorry. And I see that we already have a few in the question tab, so thanks very much for this, and please do continue to send us your questions. For these Q&A sessions, Andrea and Fabio will be joined by 2 experts from their team. So we are welcoming Laura Graciotti from Nano-Tech, who is joining to help answer your questions. And we are also inviting Lorenzo Cavalli, senior researcher at Petroceramics, to join the stage and help answer those questions. So again, thanks very much for your questions. Let's start right now. So we have lots of questions indeed. Can you provide some example of non-aerospace application for your CMC solutions, if any? This is a question from Canlock.
Okay, sure we can. We are using the CMC we presented for automotive applications. We cannot give too many information because they are under NDA. But yeah, for sure we are using that also for other applications. I don't know if Lorenzo wants to add something else.
Hello, thank you, Fabio. Yes, we have some application in the field of automotive, especially in the racing field, for exhaust pipe for automotive application, or also for the manufacturing of crucibles for high temperature furnaces.
Okay, thank you. We have another question from Anand Kumar. It's an interesting question. On a sustainable scale, how green are these materials?
So if I can, and then of course Laura can help me. It is sustainable in the extent that it is not organic polymer. So when cured, is basically a silicon oxide chain that so it's very inert compared to epoxy and other organic prepreg. So it's basically not recyclable in the extent that you will not obtain again a polymer from it. But if you will let's say grounding it, you will obtain the fiber again and the powder that is just silicon oxide.
Yes, of course, and it is important to remember that it is a hot melt prepreg, so there is not a massive use of solvents during the production.
Thanks a lot, Laura.
Thank you, Laura. Next question is from Davide Malinverno. He's asking, what is the cost of Cpreg 400 compared to the Siana tester, Epoxy, and Phenolic?
Yes, as I showed in one of the last slides, as you can see, it's comparable with the Siana tester resins. It also depends from the fiber we will use, because of course, if we will use pitch fiber or high modulus carbon fiber, the cost will increase. Otherwise, we will go even to glass fiber, so the cost will decrease. The main cost here is the resin system, because it's a patented technology. It's not easy to produce the resins, so needs know-how and care in the production process. And so this is why also the raw material are quite expensive. But as you can see from the slide, we can range from less than 100 euro square meters to up to 200, even more if you are choosing very special fiber.
Thank you, Andrea. Another related questions on performance versus cost. How are these material positions compared to competitors? Question from Anand Kumar.
Thank you. Yes, about the performance, the TG is the higher on the market. So we have not competitor about the TG, if TG we can say, because as Lorenzo also can say, the material doesn't show a proper TG. So it's decreasing the mechanical properties after 450 degrees, but it's not decreasing as for normal TG of 1 order of magnitude, but it's decreasing of about 50%, and then it's starting to increase again. Of course, the structural performance are not the same of BMI and other organic polymer, because the chemistry it's different, so it's intrinsically different. But how I said always, you cannot bring organic polymer materials for a prolonged time up to 300, 350 on 400 degrees. I hope to have answered.
Thank you, Andrea. Next question is more for Petroceramics, apparently. Did you manufacture the sandwich composites without failures or defects? If yes, what are the skin core material used?
Okay. We have developed various types of sandwich structures, basically. So to answer the second part of the question, the skin core materials, we use the ceramic foam we developed internally as a core matrix in one case. In other case, for example, we need to use, let's say, cheaper carboceramic materials in the core and, you know, better performing ceramic materials in the outer part. So basically, we can join different materials because the process of joining is particularly suitable for different types of structures and materials. And as for the sandwich structure, as for the first part of the material, some sandwich structures are currently being used in the industry, in the automotive industry. So we can get pretty good results in this direction, I would say. I don't know if Lorenzo wants to add something.
Yes, we have also special technology to join the foam, the ceramic foam, directly during the liquid silicone infiltration process. So we can obtain an in-situ joining between our EasyComp and silicon carbide foams in order to obtain structures with very high application temperature.
Yes, and this in-situ joining is particularly strong because basically you don't have, it reduces the difference between the materials being coupled, honestly. It makes it a very strong bond. And so for that reason, it is a very good solution to combine different structures. So for example, a foam with a standard composite or two different composites with different costs and properties.
Thank you, Lorenzo. Next question is from Hugues Lemaire. He's asking, do you have some data concerning aging cycle and under humidity environment aging?
Okay, our tests were performed without controlled humidity. So the data shown previously by Andrea and Fabio were performed in dry air. It's a quite interesting question. We have never performed such tests, but if you are interested, we have the capability to perform this type of tests.
Thank you, Lorenzo. Next question is from Antonio Gerbasi, who is asking if Cpreg 400 can be used combined with other epoxy prepreg, how that can be made.
Yes, if I can answer, we did some preliminary tests. We co-cured our Cpreg with ITG epoxy system. The co-curing was good, the adhesion was good, and TG was basically not affected by the presence of Cpreg. Unfortunately, we are not able to co-cure at 250 degrees the laminates in order to obtain a full mechanical properties, but we obtained the good fire properties of the laminates because the Cpreg is protecting the epoxy laminates. So you can do a hybrid construction, letting the epoxy do the structural part and using the Cpreg as a, let's say, thermal barrier or fireproof barrier.
Yes, I want only to add that a possibility is to use the Cpreg as a mold for the vacuum bagging process of the epoxy ones, due to the fact that the process parameter of the commonly diffused epoxy ones are compatible with the thermal stability of Cpreg. We have already performed some tests in this direction, and some of our customers we know that use this technology.
Thank you to you both. Next question is from Marcos Cardovi. He's asking which is the lowest recommended curing cycle.
The lowest recommended curing cycle is 180, 5 hours at 180. You can even go to 175, but if you are going lower, you should add more time. This is because the material is not showing exothermal reaction as other organic materials. And then the time and the temperature are very important. The material is still not completely cured after those 5 hours at 180. So for a very complex shape, we can even increase a bit the time of the temperature in order to achieve a better result. But I do not recommend to go lower than 170 degrees.
Thank you, Andrea. Next question is from Michael Brischkers. Is the matrix of Cpreg 400 electrical conductive after curing?
No, it's totally not conductive, electrically conductive material.
Okay, next one from Whaley. Is it available with glass fiber at the moment?
Yes, we performed some trials with glass fiber. We know that glass fibers are compatible with this resin system, and we can also prepare a batch starting from glass fiber. Thank
you, Lorenzo. The next question from Eric van Landuit. What about the shrinkage while curing? Is it similar to epoxy with around 4% in volume? Nobody wants to answer this one?
No, we don't have this data. For this reason, we're not answering. We are not this data. We can do specific tests if interested. It is for sure interesting data, but we cannot give you a specific information about this question.
The next question is how the impact behavior of the Seprec material and its energy dissipation characteristics. Sorry.
I will try to answer. We have not done a lot of tests in this in the field of impact behavior. We did some G1C test with notched Sharpie and unnotched Sharpie methods, and of course, being a high temperature material is more fragile than standard epoxy material. We are always studying to improve our products, so we are also studying how to improve this feature. I don't have data at the moment, but if we will keep in touch, we will try to answer more specifically. Thank you.
The next question is from Under Guenet, who is asking how about the possibility of these prepregs during the composite part production by comparison to the other IT resin prepreg alternative, high temperature resin prepreg alternatives.
The prepreg is extremely easy to use. So the only, let's say, difference respect to standard prepreg is that the curing temperature that is a bit higher. But if compared to, for example, polyamide, that is the main competitor, in my opinion, of this product, the processability is better, very better.
Okay. Another question. Someone is in quest of film that would have low shrinkage at 400 degrees, and it can be reusable for lamination process. Additionally, it can be released easily from laminated products. Sorry, is Seprec suitable for this purpose? Long question.
This seems to be like a vacuum bagging application, or some material to perform vacuum bagging.
I think it is connected to what Lorenzo said, that this material can be used as to prepare molds for other prepregs like epoxy based. I don't know, because it can be reusable for lamination process. So
Okay.
and it can be released easily from laminate products. So I think Lorenzo already answered to this question. So basically, it can be used to produce molds for epoxy-based laminates, which can easily be detached from the mold.
Thank you, Fabio. So we are soon running out of time, but we will take 2-3 questions. Just for your information, you have the contact of Nano-Tech and Petroceramics on screen. So if you need any more information, don't hesitate to contact them directly. Next question is from Eleonora Gianantonio. She's asking, what type of tool do you use to laminate and cure Cpreg in autoclave, aluminium, epoxy?
Okay, usually we use aluminum plate for flat laminate. We use for complex shape, we recommend to use carbon mold. It's because they have the same behavior, thermal behavior of the Cpreg you will laminate inside, so the same thermal dilatation, and is also much easier to do the molding. This material has a good affinity with aluminium, so you can use aluminum mold, but we recommend to do a very good release agent treatment before to use it. We recommend to use carbon mold because at 180 degrees, the shrinkage of aluminium will be much greater than the one of Seprec.
Thank you. Next question from Thomas MacArthur, who is asking, is it possible to purchase your resin systems without reinforcement?
Chi risponde?
Without reinforcement, we have never produced this type of resin. For example, you are talking about resin transfer molding. This is the question. To use the resin system in the resin transfer molding process, for example, our policy currently is to sell only the prepreg. So currently we cannot sell the resin system by itself.
Okay. Thank you, Lorenzo. An interesting question of Ander Gunet. Do you have any data regarding the fracture toughness of Cpreg 400 composites?
No, we don't have a data. I want to underline that also the data are strictly related to the types of fiber. So each composite should show different fracture toughness depending also on the carbon fabric or UD. We don't have such data.
Thank you, Lorenzo. We are running out of time, so I'm sorry we cannot answer all the questions you have. I have a very last questions from me that I would like to ask you. Is it possible to paint Cpreg 400?
Yes, we started to do some tests because several customers were asking to us in order to obtain also pieces that have to stay close to heat source, but need to be also looking good. So we started our campaign of test. From now we had a very good result with the normal commercial paint already used from the composite industry for aesthetical parts. So we are continuing. We want to try to have also a paint that can withstand at least 200 and more degrees without yellowing, because we would like to enter also in supercar components where the aesthetic results are very important. Thank you, Benjamin.
Thank you very much, Andrea and Fabio, for this great presentation. And thank you everyone for joining us. And thanks for your great questions. Don't hesitate to get in touch with Nano-Tech and Petroceramics. Again, you have the details on screen. I want to thank our 4 experts today, Andrea Giovanelli and Laura Giacometti from Nano-Tech, and Fabio Giacometti and Lorenzo Cavalli from Petroceramics. We have another webinar next month on April 22nd at 3 p.m. CEST with Huntsman. Huntsman automotive and composite experts will share their latest polyurethane and epoxy resin. How can they help the car manufacturer to meet their technical challenges, especially in specific automotive applications such as battery housing, interior structure, and pressure vessels. So you can get more information again on gccomposites.com, where you will be able to register for free. Thanks again, everyone, and I hope to see you again soon. Bye-bye, Andrea. Bye-bye, Fabio.
Bye.
Bye-bye.
Bye.
Thanks,
Bye-bye,
Benjamin.
Lorenzo.
Thank you.
Thank you.